Hi, everyone, and welcome to this webinar on Viya in collaboration with SAS. My name is Robert Samuels. I'm a Senior Account Executive at Blair Technology Solutions. Each year, NoviPro Group publishes annual IT Trends Report, a comprehensive study that combines data, analysis, and expert insights to help Canadian organizations better anticipate risk and identify opportunities in an increasingly complex landscape. The latest findings show that 81% of Canadian companies plan to invest in technologies over the next two years. 80% intend to modernize at least one area in their IT environment within the next year. Among these priorities, artificial intelligence stands out as one of the top five technology investment areas, with 30% of companies planning significant investments over the next 2 years. These figures help highlight both the urgency and the opportunity organizations face today. Modernizing infrastructure, maximizing the value of data, and adopting AI-driven solutions to remain competitive. To explore how organizations can turn these strategic intentions into tangible results, I'm pleased to introduce Pat Valente, Solution Specialist, Data Sciences, and Customer Advisory at SAS Canada. Pat will introduce SAS Viya, a cloud-native end-to-end data and AI platform that simplifies development, boosts productivity, with user tools designed specifically for everyone on your team, from a data scientist to a business user. Hi, Pat.
Hi, Robert. Thanks for the introduction, and I'm very pleased to be able to present this today. Quick agenda for today. I'm going to give a short overview of what SAS Viya is. We'll have a quick review of what the business challenges that we're going to demonstrate and do a solution for. And then we're going to do a little bit of, we're actually going to show the decisioning platform within SAS Viya.
Sounds good.
So for the SAS Viya overview, really what it comes down to is something that SAS has been doing for a very, very long time, which is connecting three major areas in the analytics lifecycle. And that has to do either with something around data, something around developing, models and machine learning, and something around deploying what you actually get from those models. SAS has been doing this for a very long time. In fact, we started off really as a machine learning company or as a statistical company developing those kinds of models. So we quickly had to branch back into, how do you manage all the data? How do you get access to different types of data? How do you clean it? How do you get it prepared for analytics? And then as we started to grow and talk to companies and figure out how to best implement the insights, we started realizing that deploying those insights was actually a very, very important piece. It's really the last mile of it all. And if you don't have that part of it, then the first two pieces that you do are not as powerful because you just can't get the insights to the people and the processes that need them. So that's really where the whole idea about what Viya is, what we've tried to do with Viya. And that's really just part of it because that handles the processes. But then we have to start talking about the actual technology and the actual platform. In today's world, we live in a very modern data stack where you have different players that are doing a variety of different things, and many of them do them very, very well. The only challenge, of course, is when you have all these different tools, you have to be able to orchestrate them. There's different levels of technology, different levels of expertise that's required for each one of them. So when you look at the different areas, whether it's a data source or the way you ingest it, the way you bring the data on in terms of ETL, the data warehousing, the analytics, the reporting, and so forth, there's all these different tools. And again, what SAS can do, or what SAS has been designed to do, is to be able to participate in each one of those areas. So whether you're talking about data sources, being able to do things like synthetic data, which is one of the biggest drivers now within AI, whether you're talking about ways to bring data in, SAS has been working for decades on how to bring in data in the best way possible, doing the ETL, and then of course doing all the reporting and doing the analytics and the machine learning. That's been really the bread and butter for SAS for a very, very long time. So this is where we can really help. In terms of how we sort of looked at when SAS for a long time was a very sort of monolithic structure, and we had to sort of change as the industry changed, as the environments changed. So we decided that we had to make it a more cloud agnostic platform. And so when we redesigned it for what we called Viya, we wanted to make sure that we didn't have a dependence on any one provider. So we could have we could have access to any kind of cloud. It could be deployed on any kind of cloud. It was Kubernetes based, so it had taken into account that sort of open source IT perspective. Being able to be portable, right? Being able to containerize it and so forth. So these are all the different pieces that were taken into account when we started putting together what Viya would look like. And it's a pretty hardened solution now. We launched it in 2017, and in pretty much every year since then, there's been some sort of a development, right? We went cloud native in 2019. In 2021, we made some very, very big, very, very big performance enhancements to Viya. And then in the last couple of years, we really sort of ramped up things like Viya as a service, bringing in Data Maker for synthetic data, doing things like I'm going to show today with Decision Builder. And the last year and into this year, it's going to become really, really exciting as we start teaming with Microsoft and doing Copilot that will allow AI capabilities within the interface, and doing all sorts of things around retrieval agent manager for LLMs. So this is really, really an exciting time for Viya because we keep delving into all these different new areas of the technology. I want to talk a little bit about the user personas. And I think you mentioned this as well at the beginning. The whole idea behind SAS, it is a coding language at its very heart. But when we look at the way we've built SAS out, and even through the earlier years before Viya, we've always had this attitude of, the different personas that could potentially use it. So in this particular example, you've got everyone from a marketer right through to a data scientist. And really you can take these as being, the marketer is the marketer could be a director, it could be a CEO, it could be the implementer of a campaign strategy. They're more the show me the data kind of people. They might delve a little bit into the reporting, but they just want to be able to see what the data tells them, and so they can make a decision. And as you go through the different personas, the person that's usually feeding that kind of information and getting that insight from it is the analyst. So they want to be able to use different tools, whether it's visuals, coding, and so forth, different ways to get to the data and actually do things. And then you've got the data scientist that gets really, really into the data, needs to understand everything about it, how to bring it in, how to clean it, what are the best models to put toward it, and so forth. And these are the different personas that Viya really tries to service, right? And you'll see some of that today as well in the data. And again, as we built the platform out, we had to take this kind of thing into account for the different areas and make it more available to open source users. So whether you're a data scientist and you want to use different kinds of tools, you can do that. If there's low code, no code interfaces, which you'll see again today for business analysts. And of course, if you're the person that's writing the APIs and trying to deliver these things, you can use the Open Container Initiative with Kubernetes to be able to do this. So the platform is designed to support every one of these users, and so that they can choose the interface of their choice. So let's talk a little bit about the business challenge. Today, what I wanted to look at was sort of a banking or telecom example where we're looking at improving outcome across a customer lifecycle. So take, for example, a customer that's visiting a website and they're maybe being presented a marketing offer, or they're responding to a marketing offer. And in this case, let's say they're applying for a different phone account. Could be a bank account, could be a loan, very similar kinds of applications. What typically happens as you go through the path is there's a bunch of things that happen in the back end to sort of make sure that this applicant would be valuable to accept that marketing offer. It's going to be a good fit for the company, a good fit for the customer. Things like identifying or verifying their identity, checking their banking status, their income levels, assessing them for risk, whether they've got too much debt, things like that. And really also assessing them for fraud. Is it possible that we're just responding to some sort of a bot or some sort of a fraud attempt? All these different things, all these different checks are happening in the background. And as those checks happen, essentially what happens is that different teams that are in a corporation or in a business are being brought into the mix to have their say and to be able to participate in the process. So you've got teams that are, you got the marketing teams, you've got risk teams that want to understand, that want to be able to supply the different kinds of models that they want to use to assess the risk. You've got the fraud teams that want to be sure that we're applying the right checks to make sure that there's no fraud, and same with financial crime, things like that. So all these different teams are going to be coming into the play, and if you can satisfy all those teams, you're going to get a lot of improvements. You're going to have reduced friction with clients. You're going to have a lower total cost of ownership. You're going to democratize all the data because everyone's going to be involved in the conversation as to how this onboarding journey works. And so this is very, very valuable to having this kind of a platform to be able to do so. So what we did was we created something called intelligent decisioning. And intelligent decisioning is really just a combination of the whole data operations piece, the modeling piece, mixed in with the decisioning itself. How do you make the decision? What rules are you going to use? And a lot of this was done because of the fact that we kept hearing from clients that on average, only a very low percentage of projects are actually ever put into place. I mean, that 53% that's shown there could probably have a variance on it of a large percent, but it's at the end of the day, it's way too much of a percentage of projects and things that people work on that just aren't deployed. So the whole idea is to make it so that it's easy to deploy, easy to build, easy to scale. And that's the whole reason why we built that. So what you're going to see today is a workflow based kind of environment that allows you to build decisions in real time, automate them, use different kinds of statistical procedures. You're going to see things where you can bring in code, you can do A/B tests, you can do data queries, you can dip into Python and machine learning models. You can build rule sets out and things like that. So there's a variety of things that are out of the box that you can do right with the platform. And then the final thing is to sort of show the machine learning component, which I think is really, really important as far as, again, showing some of that, the machine learning automation, the AI, if you will, that goes on behind the scenes for building the decision and so forth. So that's what you're going to see a lot of today. You're going to be able to see how we get it done with the different platforms that we have. The data itself is going to be anonymized from the banking and telco space. We're going to see visual analytics for reporting. We're going to see intelligent decisioning, and a little bit of model and a bit of model studio for the actual modeling. So 3 main takeaways, I think, for people watching this webinar is ease of use, analytical integration, and collaboration for many types of users. So what I'm going to do is I'm going to run through this process that I've built, or that I've built with the help from a few colleagues. And we've done a nice little video that sort of describes everything in detail in terms of what it's doing. Just to start off with, I think what I'll do is I'll go into full screen mode, which makes it a lot easier to work with. As we go into the SAS environment, it's a web-based environment, as I've said. We're landing on a page that basically gives you access to all your explorations and so forth. But once you start digging into the environment, and you start seeing the different areas, on the left-hand side there, you'll see that there's a variety of things that you can do. Everything from building models, exploring models, all sorts of statistical things. We're now in sort of the visualization tool. And what we've done is we've taken a data set that you can see on the left-hand side there, and that has all these different demographic and sort of indicators regarding these applications that are coming from all these different places in the world. And you'll also see on the left-hand side a variety of objects, including even machine learning objects that can be done, in a visual way. And I'll show that in a second. And it's just a question of dragging and dropping these things onto the environment and starting to link them together. And that's what we've done here. We basically said, okay, let's start taking a look at this data and start exploring what these applications look like over time. And we're starting to see that, there's a certain amount of average applications per hour. And then as we sort of scroll through the time, we start seeing that there's a bit of an increase in some of these applications over a particular hour, and they come from specific countries or specific areas of the world where we may not be normally seeing where we may not be seeing applications. So we might want to dig into that a little bit more and understand with the data we have, what does that mean? So we can look at things like, IP addresses, and we can put those on a geographic map and say, okay, with these IP addresses, how do they sort of look over time? And in the bottom right there, you see different kinds of web browsers that are being used, and you can start seeing anomalies here as well. As you go through the different countries, you're seeing that there's an extraordinarily high amount of web browsers that are used that are not identified. So that gives you the idea that perhaps this is some sort of a bot or some sort of an interesting, sort of an unknown thing that we don't really know about. We might want to look at third-party scores as well and say, well, how are those distributed across the applications? We find that, over time, they tend to be distributed fairly normally or fairly similarly. But then all of a sudden, at a certain time of day, in certain countries, again, they sort of spike as far as the numbers. So it doesn't sort of give a very good feeling as far as something being honest being done here. So again, this is very, very stark in real life. It might not be as stark, but it gives you an idea as to how you're going to build out, or how how an analyst goes through the data and gets these rules or tries to build out rules. And same with things like IP addresses themselves. Where are they coming from, right? You start to see that, again, if you look at the top 10 IP addresses, they tend to be sort of fairly normal. Like when you look at the quantities, they tend to be very normal as far as certain countries, certain close countries, to where we're located. In this case, it was the bank is or the company was in the UK. So you're expecting to see IP addresses that are more close to the UK. But all of a sudden, when you start seeing the highest IP addresses or the highest volume of IP addresses, you start to see countries that are further away. So this gives you this might be a tip off that that something is, again, a little bit amiss, and you might want to be able to dig into that. And then the final thing that I want to show here, the visual part that's really important, is the modeling piece. So again, the idea that you can actually build models, sophisticated models, statistical models, just with a visual. In this case, we've got a decision tree, and we're trying to predict fraud based on the data we have that has fraud already indicated in old transactions, and trying to understand what kind of variables are the most important in being able to predict that fraud, and what particular triggers were sort of lit across the path. What variables were sort of the most important as far as triggering that fraud that happens at the very end, which is given by the yellow boxes, the boxes at the bottom of the thing. And we have all sorts of sensitivity and other reports that you can get out of the box that give you the true positives and things like that. That's all out of the box, which is great because you can actually start building some pretty high-end models with this. Now, the most important thing is how do you take all that insight, right, and start building out a decision that you can actually use and deploy in a website with an API call or something to that effect. And so what we've done is we've created something called intelligent decisioning, which is our another interface that allows people to build, as you see there on the left-hand side, different kinds of decisions, different kinds of rule sets, lookup tables, treatment groups, all these different things that can be created for a bunch of decisions that are going to be made. So what I'm going to do is I'm going to show you a decisioning flow that we call onboarding, that has a bunch of flows beneath it that actually support the full flow itself. And I'll talk a little bit about some of the areas that we're going to hit in this decision flow. It's a fairly complex flow, but we can break it down into some pretty basic things. You'll see at the beginning there, we have something called pre-bureau knockouts. So this is like building some basic rules. If I click on that one and I open it up, you'll see that there's some basic rules that we can build that are basically if-then-else rules that basically allow us to take anything that's in our data. In this case, we're looking at age, and we're saying, hey, we want to take a look at applicants that are less than 18, greater than 60. We want to eliminate those from being potentially accepted because they might not fit the best scheme for the marketing campaign. We might want to look at certain countries that are considered to be risky countries. We might look at things like years of employment. So we want to take people that have a certain amount of employment. So those are just the pre-bureau, those are just the pre-knockouts that we can create. And then we can go into identity verification. And identity verification, again, can sort of open up another flow where we can apply some of the different things that I talked about in the exploration, right? So we can start looking at IP addresses, IP distances, and things like that. And we can build specific rules that take into account just the ID verification. So we can look at, the IP distance. So we talked about, how far is the application from the country we're in? Is the country listed, is the IP address listed in a country that could be associated with financial crimes? And we can start eliminating those users from the applications, or creating a rule where they are more likely to be rejected for the application because they might be fraudulent. And then we can also start looking at things like checking the demographics, right? So taking a look at, again, the score that we were talking about, saying, okay, when we start seeing scores that are significantly greater than what we know is sort of the average score or the average distribution, we can start either approving them or disapproving them based on what we think is fraudulent. So again, that takes into another layer of identity verification based on what we discovered with just the visuals, right? But now we're sort of putting it into a rule that can actually be run as part of a flow. So that's the identity verification part. As we move through this piece, we're now going to talk a little bit more about sort of the credit assessment, if you will, or the credit risk. And if we open that one up again, that leads into a couple of different areas that are really, really interesting. One would be the income verification piece. So we talked a little bit about understanding what a person's income is. In this case, we have an interesting decision flow that does two things. One, it sort of it asks the question as to whether or not the customer will allow us to have access to their open banking information if they have such a thing. And that just basically reads into a Python code that grabs that looks at that API and grabs their banking information. And if we don't have their banking information, we can apply a machine learning model that we've built in another flow, which I'll show in a second, that actually estimates what their income might be based on all their demographics, what they've told us about their job and things like that. So we can determine what their income might actually be and be able to sort of move through the process that way. So that's one way that we can actually start bringing in machine learning, and we'll see a little bit about how that's actually built out. This particular flow talks about the credit policy, and it compares two scorecard models. So when you think about scorecard models, think about the distribution of scores that I was showing before, and trying to figure out which scorecard model might fit best to describe whether those scorecard scores are correct, right? So we're basically comparing two models there to decide which one might be best. And then finally, to talk a little bit more about the actual model building process, we've got something that talks about the actual risk of bringing on a customer and what we think their lifetime value would be to us, or what their lifetime tenure would be for us. And so what we've done here is we've delved into another machine learning model, and I'll go into the actual interface here to show you what that looks like. So here we've got data on a telco customer, or the bunch of telco customers, their average usage, how long they've been with the company, any fees that they've paid, and things like that. And you'll see the target at the bottom is the tenure. So that's the tenure in months. That's their target level, and we can start taking a look at all that data, and we can start comparing, or we can start making assessment as to what we think is the average lifespan of that customer. And typically, what happens here is you build out a tournament of different kinds of statistical models, all out of the box with nodes that basically can be customized or ran as is. And in this particular case, originally we had the gradient boosting model that was the winning model, but when I reran it, the linear regression went out, and we'll show that, and I'll show you why that's important in a minute, because we're going to update the model to sort of showcase that. So that's how we can dip into machine learning to bring that kind of information into the flow. And then finally, when we take all these elements into account, we can come up with our final subscription fraud flow that actually takes all the pieces that we brought in from before and basically assesses them and takes it against the scores against new data, where you can actually run a test to understand which of the rules for each of the variable or for each of the observations, which of the rules are actually firing off or are actually triggering. So here you're getting the data set that actually shows which of all the rules that you've built is being flagged for each one of those observations. You can get some nice plots that show the distribution of the different kinds of rules and which ones were more popular than others, or more populous than others. And you can actually get a nice little also analytical flow or a plot of the different rules that were fired along the path for each client as they went through the website, and we're giving their data, and we apply all those different rules. So you can get a nice little sort of a nice little schematic of the different paths that led to all the either the acceptances or the rejections. And you can get some nice node counts as well. That's just more of a tabular format of the original bar chart. And then finally, to publish this is very simple. We've got a publishing button that allows you to basically push to something that you can do in batch. You can do it to a microanalytical service that can be called by an API. Publishing the report is as easy as that, or publishing the model is as easy as that. Now, I did say that, you know, in the actual model studio where we built the model to predict customer lifetime, I did mention that, you know, I reran this tournament, and I found out that when I reran it by applying some different models, the linear regression model actually went out. So what happens in real life when this happens, right? You got a new model that's a champion, and you want to apply that to the results. Well, now what I'm going to show you here is what we would do in the back end, sort of in a manual way, but you could actually build a job to do this, because basically what's happening is you're getting a new champion model. So really what you want to be able to do is to basically register that model. So the first step is to say, okay, we've got a new winning model. We're going to register that model, right? When we register that model, it's going to put it into the list of applicable models that can be called upon by the decisioning solution. And that's what's happening here. And then we can go back to the decisioning solution, and we can go back into the flow, and we can say, hey, I've got a new model that I want to be able to pull from that from that tournament of models. And again, this is something that I'm sort of showing, I guess, in a manual way, but you would build a job to actually say, hey, when we run that tournament over and over again every day or every week, you're going to take the winning model. So it's looking at the repository of these models that are being that are available. Who's the champion model? Pick that model and update the entire flow. And when you update the entire flow, what should happen as you continually run this decisioning flow against new data is that chances are, because of the updated information, what should happen is that some of the variables or some of the outcomes that you see should change in some way, shape, or form, depending on how popular that model is. So I want to end the demo there, and just be able to say that if you have any questions about data and so forth, love to talk to you and be able to show what we can do with getting some of the insight for you, and be able to work with Blair, and be able to show you how we can take your data, get you insight, and show you how you can actually deploy it.